Greetings to all, uh, and welcome to the session 5 of the Unit 1 of MCAD Laboratory. Myself, Mohammad Imran, lecturer in the Department of Mechanical Engineering, Government Polytechnic, Karwar. So in the today's session, we are discussing the following content, getting started with the solid edge, getting base features by protrusion, advanced modeling tools, and last, at the end, we have discussing a small multiple choice question. So getting started with the solid edge. So in the earlier 4 session, might have studied basics about the solid edge. That means how to open the solid edge and solid edge working environment, and what are the basic features of the solid edge. So solid edge is a Windows-based software. The environment setting and start methods are very similar to the any Windows application. So if you have used any Windows application such as Microsoft Office and Microsoft Excel, how you'd open the Microsoft Office or Microsoft Excel by going to the start menu and click on the Microsoft Office and Microsoft Excel. The similar way, the solid edge will be opened by going to the start menu and searching for the solid edge and click on that, it will open. And also you can keep a shortcut on the desktop, and by double clicking on that, you can also open solid edge. So once you open the solid, you can see the following page, display page. So these are the 5 working environment of the solid edge. We have solid part here, sheet metal part, weld met, assembly, and drawing. So from the syllabus point of view, you have solid part, assembly, and drawing. Today we are discussing some important and base commands in the solid part. So the first important base feature of the solid edge is a protrusion. And what is protrusion? So protrusion is a process of adding the material by drawing any sketch, a closed sketch in the direction normal to the sketch. It means adding the material to the drawn sketch in either perpendicular direction. So it is just nothing but adding, making a 2D sketch into a 3D element. So we'll explain it by a live example. So once you open the solid edge, we can see this entry screen. So these are called as planes. This is front plane, this is top plane, and this is side planes. The planes are very important in drawing any solid parts or maybe sketch. So this is the protrusion command. It will be available in the future toolbar here. This is the future toolbar, and this is the protrusion command. Click on the protrusion command. Once you click on the any command in the display, it will show the what are the procedure to be followed to achieve that command. So here it is saying click on the planar surface or reference plane. So in which plane you are needing a protrusion. So I am selecting the front plane. Once you select the plane, it will automatically go to the sketch mode where you have drawn the sketch. For that, the material will be added. So I'll draw a simple rectangle. And make a dimension for this. I need this is 150 and I need this as 100. So I'll constrain it by making it a center to the plane. Go to smart dimension, move this dimension from here to here. Since it is 150, I'll make it a 75 so that it will come at the center. Similarly, this is 100, I'll make it this from center as 50. So now this rectangle at the exact center. So now I'll click on the return. As my sketch is completed, so I'll go to the return from the sketch mode. So one thing you have to note at that the profile of the sketch should be closed for protrusion. Return. Otherwise, it will show the error. I'll click on return. It will return from the sketch mode. See here. Now it is material adding here. This is the one command. So you have different option here for adding material. This is non-symmetric extent. What is non-symmetric extent means it will add the material in one direction only. See here, it is adding in one direction only. Either this direction, if you keep cursor in this direction, it will add this direction. If you keep cursor in this direction, it will add material this direction. You can enter the how much depth is required here. So another one is here symmetric extent. Symmetric extent means what? It will add the material in a direction equal length. So here if I keep up, I will enter 100 mm. So it will add material 50 from here, 50 from here. This is sketch profile. From it will add the material equally in both direction, here and here. This is the symmetric extent. So I completed the protrusion model here. Then click on the finish. So this is the process for drawing protrusion. You can draw any for closer sketch profile, and you can add on material by protrusion command. So next we'll move on to the cutout command. Afterward, we'll study about the revolved protrusion. So what is revolved protrusion? Revolved protrusion means it is similar to the protrusion. Here, the material will be added by rotating any section along the reference plane. So suppose we have any shaft, its cross section is similar throughout the 360 degree, or maybe a stepped shaft, or maybe stepped cone. So these are having a same section. If you cut anywhere, it is having same section, and it is revolved around 360 degrees. So that kind of materials will be produced or created in revolved protrusion. Let us explain with the live example. File, new, part drawing.pr for drawing solid part. Okay. So here next to the protrusion, we have revolved protrusion command. Click on that. It will say select the plane. I'll select this plane. Plane. So next you'll go to the sketch mode. Here I'll draw the closed profile for revolving. Here, this is the closed profile I have drawn. So whatever profile you required according to the dimension, you need to make a dimension for that and to draw. So this is the closed profile. And then after that, after drawing the sketch, a closed sketch, you have to mention the reference plane, about which reference planes you have, this section has to be rotated. For that, you have to click on the axis of revolution, click on the axis of revolution and select this plane as a axis of revolution. So with respect to this axis, this will rotate. Now click on the return here. It is a revolve command here. So here the two options is there. You can keep 360 degree throughout material, or you can give a finite angle. If you want only this rotation, only 180 degree, so you can give 180 degree or 90 degree, whatever angle you can required, you can enter here. I need 360 degree, so I'll enter 360 degree. See, click finish. So this is the revolve command, revolve protrusion here. Next, we'll move on to the sub protrusion. What is sub protrusion? Sub protrusion means you might have seen the elbow pipe, how its section is like so how to draw in, but in protrusion or in a revolve protrusion, not possible to draw in a simple protrusion command or revolve protrusion. So here in swift protrusion, you're drawing a section and a path. So that section will be added material along the path we have defined. For example, a elbow, you have cross section of a circle, and its path is like elbow shape like this. Yeah. This is a section here. Section is a circular and its path is a rectangle. Its path is like this elbow shape. So we have to first initially you have to draw the path for that, and then you have to draw the section for that. Then you have to give the swept protrusion command. We'll discuss with the live example. File, new, part. Okay. First, I will draw the path for that in the front plane. Go to the sketch command, select the plane, select the path. So whatever path is required, you have to draw with the dimension here. Here, this is my path. This is the path. Then you have to draw the section. And click on the return. So for drawing section, the plane should be perpendicular to this curve. So for that you have one option here. Go to the sketch here, click on plane normal to the curve. So I click on the end of this curve. It will create a plane here. See, normal to this point. So click on that. It will automatically go to the sketch mode. Now you will draw a section for this. This is a section. Click return here. This is the section now, and this is the path. So now I'll finish, and then I'll go to the swept protrusion here. Click on the swept protrusion. It will ask for a single path section. Click on single path section. So now clear the section. I'll select the path for that. Click OK. Then click select on the section. See here. You can see here how it is created the protrusion along the path. So now it is very difficult to draw in a. It is not possible to draw in a normal protrusion or revolved protrusion. Should be drawn in swept protrusion only. Okay. So in exact dimension, whatever you want, you can give, and you can create this protrusion. Now we'll move on to the next command. Lofted protrusion. So what is lofted protrusion here? Lofted protrusion means it will create the part by adding two different sections. Here you can see this is one section and this is one section. Similarly, you can draw any different text section also. It is circle only. You can draw different profile also. Any from here triangle to here circle, or rectangle to circle, whatever, and more than one section you can add. So whenever we are adding the material or creating a part by adding two different sections, that is called as lofted protrusion. So we'll explain with the live example. File, new, part. Okay. See here. For that also you need two sections. First draw the two sections here. So first section I'll draw here in the front plane. Go to the sketch, front plane. Here I'll get this dimension from this 60. Diameter circle, return. Then I create a parallel plane, so that I need section here. If you know the height or the distance between that, exactly you have to create a plane according to that length. So finish. Then I'll again click on the sketch. I click on this plane, done. I'll click on the parallel plane. So from here, parallel, I need a plane parallel to this. At a distance, whatever you want, you have to put enter here. So I'll put 160 here. So now draw another section for that, different section. You can either draw rectangle, triangle, or anything. I'll simply draw a circle. So that will become a frustum of cone. Click on return. Now click on finish. Now go to the lofted protrusion here. Click on the lofted protrusion. It will ask for select the sketch or curve. I'll select this first curve. Then click on the sketch on the edge or curve. I'll click on this sketch. Then I'll go and click on the preview. See, it has created a different section, which just like a frustum of cone. So here I told you already, you can draw any profile and more than 1 to 2 sections, but minimum you require 2 sections. Okay. This is about a lofted protrusion. Then we'll move to the next command. Cutout option. So what is cutout option? So earlier commands what I have studied is only adding the material. So this cutout is removing the material from already created solid part with the section what you have drawn. So ಇದು ಒಂದು material removal operation ಇದು. So whatever the profile is you have to need required to cut, so that profile you have to draw on already created solid part. For cutout part you require a solid part. Without solid part you cannot make a cutout operation. Let us discuss with the live example. See, I need a, this is an already created part, so I need a cutout here in a rectangular portion. So I'll go to the cutout operation here. So this is the cutout operation. Next to the protrusion command, revolved protrusion command, we have cutout option. Click on the cutout option. It will ask for the plane or surface where the cutout is required. I need a cutout on this plane, so I'll click on this plane. It will automatically move to the sketch mode. Here you have to draw your profile, which has to be cut out. Here I'll draw a rectangle. Here I need a cutout here, a rectangle. Any shape you can draw. You can draw any shape, whatever shape is required. A cutout, you can draw any shape here. For example, for teaching example, I'll give a simple rectangle here. Then click on return from the sketch mode. See here, the direction is important. You cannot give direction in the up direction because there is no material in the upward direction. You have to give the direction cursor. You have to keep the cursor in the downward direction only. Here also symmetric extent, everything is there. I need a distance, a depth of 50. I'll click on the 50. This direction. See here, 50 depth is created. 50 depth cutout is created. See here. So any profile you can draw here to make a cutout. So for important thing is you need a solid for making cutout. So then only you can make a cutout. You have to draw any profile which has to be cut, and click on the cutout option and give the depth. Click on finish. See here. This is about cutout operation. So next we'll move on to the revolved cutout. So what is revolved cutout? Similar to the revolved protrusion. Revolved cutout is the opposite of that revolved protrusion. Here, there we are adding the material by revolving the part. Here we are removing the material by drawing a profile and revolving around it the solid parts. Already created solid part we required for a revolved cutout, and you have to draw a closed profile. According to that profile, it will remove the material by revolving that section. So let us discuss with a live example. Protrusion. I'll create a solid part first. Without solid part, we cannot move the revolved cutout operation. Return. I'm making a cylinder here. Return. Finish. Now on this part, I will make a revolved cutout. Go to the revolved cutout operation. Click on the plane where cutout is required. I'll click on the front plane. So draw a profile here. So I'll draw a rectangular profile. I'll make it fillet. Then I'll click on the, it should be also a closed profile, and then I'll click on to the return here. Here, yeah. An important thing is similar to the revolved cutout operation, you need to give the reference of axis of revolution for the revolved cutout also. So I'll click on the axis of here, close this error. I'll select this as an axis of revolution, this plane. Click on the return. Then it will revolve, and it will remove the material like this. I'll give 360 degree here. Here, according to this section, it will revolve and remove the material. This is about the revolved cutout operation. You can draw any profile whatever you want to make a cutout, and you can make the revolved cutout operation. So next we'll move on to the advanced modeling tools. In advanced modeling, we are discussing about hole, thread, round and chamfer, mirror copy feature, rib and macros. Let us discuss with one by one. First, we'll study about thread. So what is hole and thread? The hole and thread is required for either for fastening purpose or any other purpose, or for oiling or any other purpose. So we'll study about how to make a hole and a threaded hole. Okay, we discuss with the live example. Here I need a circle here, hole here, threaded hole in this portion. Then you click on the here hole option. Click on the hole option. Then you click on this hole option. Click on that hole option. The whole option table will come. Here you have to select a simple threaded hole here. If you need only a simple hole, you click on the simple hole. I need a threaded hole, so I'll click on the threaded hole. I need a you have get a standard hole size here, so I will select on a standard hole size. Whatever you want, you can write here also, and you can get the standard hole size also. I need a M30 hole with a 3 mm pitch, so I'll searching for that. So I got here M30 into 2 pitch, M30 into 3, M30 into 2, M30 into 3, M30 diameter and 3 mm pitch. So it will ask for the, this is the whole extent and this is finite extent, but that means the whole diameter should not be same as a thread diameter. So if you want a whole thread hole as a fully threaded, to give the, you have to click on the whole extent. That means what? If you have a hole of 50 mm depth, throughout the whole depth, thread will be created. Or you want either exact dimension then you can click on the finite extend. That means if a hole is having 50 length and you need a thread on only 10 length, then you have to click on the finite extend and length, enter the length required. So I'll keep on hole extend. That means it will be created to the throughout the whole depth. Here this portion is for a whole purpose. Here four option is there. One is uh, through all, means if you have any solid parts throughout that part, the hole will be created from start to end point. Here the next option is through next. Through next means if you're having three or more surface, if you click on one surface, up to that the hole will be created. The next option is from to extend. If you have three or more surface, from one surface to second surface you have to select. For example, you need a hole up to third surface. You click on first surface and click on the third surface. It will create a hole up to that third face or third surface. Next, here you how much length required, you can directly enter. Suppose you know the exact length of the hole, here you can enter. So I'll enter here 60 So since I have given here to hole extend, the thread will also created for 60 length. Click OK. Click on the linear. See here. Then click on the so already M30 hole will be created now. Now you have to keep which position you have required. So I need here exactly in the center. If you aren't anywhere here, then you have to keep here and give the dimension for that if you know the exact dimension. Then I'll click on the return. So here I have created 60 I've given 60 length, 60 depth hole is created. So here the thread is not seen, but this it's a threaded hole. To see the threaded portion, you have to go for a format view option here. Here you click on texture, then you can see the thread. See here thread. Since I have given thread to the through a hole extend, it is created for 60 length. Thread also created for 60 length. This is about simple hole and thread creation. So next we'll move on to the next command, that is chamfer and round and chamfer. What is round and chamfer? So this is the process of removing the sharp edges from the component or any material. So what will happen if you keep a sharp edges or material? What will happen while handling the material or during machining or transportation purpose? It may damage the your hands. It will damage your hands. To avoid that, the chamfer and round option will be produced on the material. What is round means it is created. It will remove the material in a circular shape. Chamfer means it will remove the material in an angular. Here you can see the difference between the chamfer and this is round and this is chamfer. So we'll explain it by live example. Here. Click on the chamfer command here. First I'll click on the round command. Here you both option here will be available here. I'll click on the round option. Here chain is there. I'll click on chain. I'll make it as edge and corner. Chain means if you click on this edge, the whole connected edges will be selected automatically. Chain means it's a closed profile. So if you click on that, whatever it is connected to this, everything will be selected like this. It is this edge is connected to this edge, this guy is connected to this edge, and this is connected to this edge. So whole corners will be selected. I don't know that I don't need that. I need a particularly selected edges to be rounded. So I'll click on edge and corner. I will select this edge, and this edge. So radius is there. You can change the radius whatever you want. I'll make it 10. See here, review, finish. Here 10 mm chamfer, radius chamfer is created. So here I'll make a chamfer here. So this edge. Click on the chamfer command here. Below to that, have chamfer command. Click on the chamfer command. Similarly, have chain option. Click on that. Select corner and click this corner, this corner, this corner, and this corner. It will ask for setback. Setback means how much distance chamfer is created. I will put enter 10 mm. Here, this distance is 10 mm here. 10 mm chamfer is created. If you know the exact dimension, that means it will be given in the drawing 2 into 45 degree or 3 into 45. Then you have to enter that setback here. Okay. This is about chamfer and the round option. Next, we'll move on to the next command. Mirror command. What is mirror command? So if you are if the component is having the same feature in the other direction or other plane, so instead of drawing two or more profile, you can simply mirror the that feature. It will minimize the modeling time. So here we have two parts here. So it is in the same distance from the plane. Instead of drawing two profile, we can draw one profile and mirror it according to this plane. So it will automatically create a mirror of this component. Let us discuss with the live example. I'll create one feature here. Protrusion. Return. Here. Finish. So this component is also here also. So instead of drawing again, go to sketch and drawing this profile. You can. This is about one feature. If you're having more than 10, 15 features every time, you cannot draw 15, 20 features every time. So instead of that, we can simply mirror this. So click on the mirror copy feature. It will ask for select the features to be mirrored. I will select this copy. This feature has to be mirrored. Then I'll click for OK. Click OK, right mark here. Then it will ask for the plane surface about which it has to be mirrored. So I'll exactly, it has to be mirrored from with this plane, center plane. Click on that. See here. You see in the top view, this distance and this distance is similar. Similarly, if you have planes here, any feature here, you can mirror with respect to this plane. Here it will be created here. Okay. This is about mirror copy feature. Then we'll move to the next command. Creation of rib. What is rib? Rib is a thin-walled feature. It is used to withstand take the load from the two weak bonded surface. See here, these two rectangular surface. These are the two surfaces. It is joined here. So this joint portion may not be strong. So in order to make it strong to withstand load, we will create the rib. This rib will take the load of these two surfaces. You can see in the plastic components like chairs. Below that chair, you can see the ribs because it is used to bond the two surfaces so that it will take up the load of these two surfaces and make a strong bond. So let us discuss with the making creation of a rib with a live example. See, this is the two surface. It is joined here by welding or anything. That it may not be strong. It is bond. It will not be strong. We will make it strong by creating rib here. So for creating rib, you go to the rib option here. You can see a rib option next to the mirror copy feature. You have rib option in the future command. Click on that. Then it will ask for a planar face. A plane which rib has to be created. I will select the exact center plane. If you have to create in any particular place, then you offset this plane by the distance you know where you have to create the exact rib. Then you can offset or make a parallel plane to with respect to this. So I have, since I have the center plane here, I will click the make the rib on the center plane and click on this center plane. Then I will draw a line here. If you know the exact dimension, you can draw the exact dimension of it. Also, you can draw the line from here to here also. I will make a line from here to here. Only a single line. There should not be any need of closed profile here. Only should have to draw a line from this surface to this surface. Then turn option. Here, the direction is important. The arrow of direction should be inside the inside towards the inside surface. It should not be outside the surface. It should be inside the surface. Then you click on the thickness here. I click 5 mm thickness, and direction should be here. See here. It has not created. So the direction I have changed, the error will come. Let us again. I will make a rib option here. See here. Finish. The rib is created. A 5 mm thickness here with the line drawn here from here. You can draw the line from this end to this end also. So I need a rib up on this portion only. So I have drawn the rib here. So it will take up the load of this surface and this surface and make a strong bond between this. This is about rib option. Next we'll move on to the macros command. What is macros here? So in case of while drawing a pyramid, hexagonal pyramid, pentagonal pyramid, or any polygons. So you have to draw in the sketch every time you have to draw a line, and then you have to keep an angle of 6. For example, if you are drawing a hexagon, then you have to draw first you have to draw a line, a straight line of 90 degree, give the dimension for this, and maintain the 60 degree here. Again, you have to maintain the 60 degree here, or you can draw 3 profile and mirror it. So it requires more time. Instead of that, the solid edge have a default polygon command, so that is called as macros. You can draw any polygon, 5-sided pentagon, 6-sided hexagon, 8-sided octagon. So whatever profile polygon you can draw by simply entering the side length and number of sides. So I will we'll discuss with the drawing a pentagon, 5-sided pentagon with the macros. For drawing these macros, you should be in a sketch mode. So in the default, the macros will be in go application. This has to follow. File. You go to the sketch mode. Only in the sketch mode you will get the polygon. So in the part model you cannot get a macro. So for that you have to go to the sketch mode. So here you click on application, macros, run macros. Here you can n-sided polygon. So it will be available from path for selecting this is go to the C drive. Then you click on the program files. You click on the solid edge, solid version. Then you go to the custom. Then n-sided polygon here. Then you click on bin. Here n-sided polygon. So this will come here. Here you can draw any number of sides. If you draw 5 sides, it will become pentagon. If you draw 6, it will become hexagon. Similarly, whatever sides you want, you can draw. I will draw a pentagon. So pentagon of 5 sides, and I keep it on a radius from flat. Radius from flat. Radius flat from this distance. So I need here given 30 mm. I will give on the click on the flat length. Flat length is this length. So it will be given in the problem or any component. So this flat length I will put 30 mm. That means it will create a pentagon of 30 mm side. Then you select the point where the hexagon pentagon created. I will click on this center of this. Here the pentagon is created. So if this option is not there, then every time you have to draw a line, maintain 72-degree, and every time you have to keep on drawing. It will take time. So instead of that, you can use the macros so that you can readily you can draw the polygon directly. This is about the pattern. For this portion, you can make anything, extrude option or cutout option, anything you can do. This is about macros. So with this, we end up with this session. So now we'll have some multiple choice question. So based on the whatever studied in this session, we have some simple question so that we can understand it very efficient way. So first question is solid edge work on which environment. So in the beginning initial slide only I said the solid edge works on the Windows based environment. So I told you how I will make Windows other softwares like Microsoft Office, Microsoft Excel. Similar way you have to go to the start menu. So that means solid edge work on which software, and the option will be Ubuntu, Windows, Linux, and Mac. So it is a Windows. The answer for this environment, software environment, is Windows. So next is protrusion command is in solid edge used for. So in the beginning only we have studied first feature, the base feature of the solid edge is protrusion command. I explained it by drawing a rectangle and adding material in the normal direction. So that means it is creating solid part from the sketch. So the option we have creating hole. It is not the whole making command. It is not the revolved part. This is not the removing material, and this is about creating solid part from the sketch. Removing the material is cutout operation. Revolved part is a revolved protrusion. Creating hole is a command. So creating solid part from the sketch is the correct answer for this. Next, cutout command. The next question is cutout command is available in which toolbar? So I told you the cutout command, protrusion command, revolved protrusion, everything is available in the future toolbar. When explaining, I keep on telling that it is available in future command. The option for this is sketch. In sketch, we draw only 2D draws. So in future command, we have the cutout operation. Pattern is making a mirror option. Tools is a toolbar. So next question is, which command creates the part by extruding profile along the open or closed path? So I explained by a elbow pipe how to draw a elbow pipe with a section and a path. So the option for this is cutout. Cutout option is a material removal process. It is the material adding process here. So this option will not be correct. Next is revolved protrusion. Revolved protrusion will make a part by revolving around a reference axis. This is not about revolved protrusion. And lofted protrusion is it will create the section. It will create the part by two different section. Here we don't have two different section. This is the swept protrusion. Swept protrusion is the making the material by adding the material along the section and the path. So a correct answer for this is swept protrusion. Swept protrusion. Next question is, which command creates the part by joining two or more different profile along the path? So this swept protrusion we have studied only when required one section and one path, and revolved protrusion it will add the material along the radial direction. Lofted protrusion is the correct answer. Lofted protrusion will make the part by drawing two different sections. So the correct answer for this is lofted protrusion. The sixth question: a thin wall like a structure used to bind the joints together so that they do not fail under the increased load. It's called as what? So I told you by drawing a rib. So it will take up the load of two weak surface. It will make a strong bond and it will take the load of the two surface. So we'll look onto the options here. Draft command is used for making a pattern allowance for easy removal of the pattern. So it is not a correct answer. Rib option is there. So rib is the correct action. Chamfer is making removing the sharp edges, and cutout is removing the metal from the solid surface. So correct answer is the rib. Which command in the solid edge is used to create the default polygon in sketch mode? In the end, we have studied about macros where we got a n-sided polygon here. We created already default created polygons. Just we have to enter the number of sides and that length required. So that option is macros. The correct answer is macros. So the pattern will create the number of copies of the same feature. Mirror is making a mirror of the one created command. Mirror copy and mirror copy are same. Macros is the correct answer. Okay. So this is the reference where we have taken this data from the source. At the end, this is our team. I'll thank each and everyone. These are the chairmen, moderators, and subject experts in our team. They helped me to make this presentation. Thank you all.